we're going to review trig rules here, which means we're going to go over some of the rules you're supposed to have already known. Now, we have 4 triangles below. Okay. 3 of them are very similar. Can anyone name the 3 of them? The right angle triangles. Okay. Before we go any farther, I want to talk about what rules or laws can we use with right angle triangles. So we're going to list them off here, Jeremiah.
Two of the sides have to add up to the hypotenuse.
Okay, so Pythagoras Theorem. So a squared plus b squared equals c squared. Okay, so the squares of 2 of the legs have to equal the square of the hypotenuse. Okay, c always being this part here. We'll call this a and we'll call this b. That's one formula. Okay, what's another one? SOHCAHTOA. Okay, so we have our sine x is equal to opposite over hypotenuse, those 2 legs. We also have cosine x or theta is equal to the adjacent over the hypotenuse. And we also have tan x is equal to the opposite over the adjacent. Essentially, that's what the SOHCAHTOA stands for. So as in S, and then OH. Ka is CAH. And TOA, that's supposed to be a T, OA. Okay? That's a way to remember our 3 primary trig ratios. Anything else you can use? Did we learn any other ones? Sine law. You can use sine law on a right angle triangle. Okay?
On any triangle.
In fact, you can use it on any triangle. Good. But, so we have our sine law. The only thing is, you may not have enough information because in order to solve sine law, you need at least 3 bits of information. But using SOHCAHTOA, you technically only need 2 bits of information. Okay? That's with right angle triangles only. So we're going to set 1 or 2 or 3 of these up. The very first one, we'll jump through quickly. We're going to call this A, B, and C. Okay? And we'll call this also A, B, and C. So let's say I'm talking about this angle here. We'll call this our angle X, and we'll do it 3 times here. That's a very good point. Let's actually talk about it that way instead. Because for our laws, what we're going to be doing is we're going to be renaming triangles. So instead of calling it angle X, we're going to talk about how to actually rename triangles. So if this is my side A, the angle opposite of that will be angle A. Okay, so we have to learn how to name our triangles. So this is angle A, which means this is opposite angle B, and then opposite of C, this would be angle C. So in all of our cases, the right angle is angle C, and again, the opposite corner is the same name as our opposite side. Now, with that being said, you can rename triangle any way you like. Pythagoras Theorem is written with A, B, and C, so we've written it this way so we get used to it. Also, we normally call the angles the uppercase letters. Okay? So I'm going to actually change them to the uppercase letters when we do this. Just for when we go into sine law, cosine law, and sine law, we're writing these as uppercase letters. So that would be A, B, C. I know the C doesn't change. Okay. So we've named these triangles. If I wanted to set up sine of angle B, sine of angle B, how would that ratio line up? I just want to line up the ratio with the information I have. Okay, so I'm using sine B. How can I write that ratio? Sine B, so that's angle B, is equal to what sides? All right, the opposite, which is our B, over the hypotenuse, which is C. So sine B would be equal to B over C. Okay? All of these things can change. What about if I wanted to use, in our second example, cos B? So cos B would be equal to what? Still talking about this angle because that's our B. That's right. Our adjacent happens to be A and our hypotenuse is C, so that would be A over C. Say, same idea, tangent B. What is it? That's right, opposite over adjacent gives us our B over A. Okay, and technically those should be lowercase. B over A. Good. All right, so we've done that. Those are setting up the primary trig ratios. I don't think you guys were as bad with those. Okay? But remember, those only work with right angle triangles. We cannot use them unless we know it's a right angle triangle to solve anything. The last one here, I'm going to name this RA, which means this becomes side A. This will be angle B, which means this is side B. And this is angle C, which means this is side C. The last formula is sine A divided by angle A is equal to sine B divided by angle B, which is equal to sine C divided by side C. This ratio can be flipped. I can also rewrite this as, and it's the exact same thing, A over sine A, B over sine B, and C over sine C. Yes, it's a test. I'm not supposed to tell you the answer to the test. So, we have this. You can flip them. It doesn't matter if you do it the first way or the second way. And in fact, when we flip them, we can make questions a lot easier depending on what we're looking for. Okay? Now what we're going to do is I'm going to make up a triangle here. We're going to take some information from a book. It's a mid-chapter review. So let's take these two here. We'll make another triangle. And those are all right angle triangles. Don't need a right angle triangle. Yeah, let's pause this for a second while I find it quick. Okay, so this is not drawn to scale, this triangle at all, but these are the measurements of some unknown triangle, okay? First of all, I can already find one piece of information extremely quickly. Does anyone know what that is? I can find the last angle by doing what?
Subtracting by 180.
That's right. All of the angles in a triangle need to add up to 180 degrees, which means to find out our last angle, we usually denote it as something called theta. But I'm going to name this triangle because eventually we're going to use Sine Law. So I'm going to call this angle A, which means this will be side A. Angle B, which means this will be side B. And angle C, which means this will be side C. We know to find angle A is equal to 180 subtract 45 subtract 80, which ends up being 100 minus 45, which is what, 55?
Yeah.
So angle A is 55 degrees. So we've already found another piece of information. Great, we have all of the angles. I have one side measurement. Can I use the primary trig ratios to solve this?
No.
No, why not?
Because it's not a right triangle.
It's not a right angle triangle. I cannot use those. I can only use them with right angle triangles. So that takes many things out of the equation. For what we've learned up to this point, the only thing I can technically use is what? Sine law. So let's set this up. I'm going to be looking for the two sides in this case. So I'm going to set it up like this to start. I'm going to set it up like this to start. Okay. I'm going to fill in all the information we have, and then we're going to figure out what ratios we can use. Each of these is a ratio. If you guys think back to grade 6 when we talked about ratios as fraction, these are all equivalent ratios, saying that this ratio is equal to this ratio, which is equal to this ratio. They're exact same. They're all supposed to be equal when we put them all together. We only need 2 to solve something. So let's put together our information. We know angle B is 45. This is the angle. The uppercase is the angle. So sine, the letter, means we're talking about the angle. Sine A is 55, we just solved that, and sine C is 80. So we're going to plug those pieces of information in. And we also know side B is 7 millimeters. So let's put all this information in. That becomes sine 55 divided by A is equal to sine, our B was 45?
Yeah.
Divided by B.
No. 7 millimeters.
Good. And sine C is 80 divided by C. Now we do know side B, so we're going to erase this and put in our 7 for the 7 millimeters. I have one complete ratio. In order to use sine law, I must have one complete ratio. Otherwise, I have to use something else, which we're going to get into today, which is cosine law. But I have this complete ratio. So whether I'm trying to solve for A or C, I'm going to be referring back to this ratio in the middle. Okay? So we're going to set up two equations here. We'll flip it in a minute. Okay? So we'll do A in red, and we'll solve for C in green. I put parentheses or brackets around the ratios we're going to use. So I'm going to set sine 55 divided by A equal to sine 45 divided by 7. And the other one, I'm going to put sine 45 divided by 7 is equal to sine 80 divided by C. Okay? Now remember, our goal here is to solve for A or C. Either one. Now, since those are the unknowns and they happen to be on the bottom of this question, it'll be a lot easier to isolate them if we were to flip the entire equation. Remember I told you it didn't matter if the angles were on top or the sides were on top, the equation still stays the same. The ratio still stays the same. Think of it as if we had two equivalent ratios where we actually knew the values. So if I had 1 over 2 is equal to 5 over 10, do you guys know this to be true?
Yeah.
You're okay with that? Okay, so this is a true. This ratio we know is equal. But what if I flip both of them? 2 over 1 is equal to 10 over 5. Is this still true and equal? Yeah, it's still true and still equal. So we can flip equivalent ratios all we want to make things easier for ourselves in math. So because I'm trying to find A, we're going to flip this ratio. We're going to put A over sine 55 is equal to sine 45. Oh, sorry, thank you. Good for you. Yes. 7 goes on top. Sine 45 goes on the bottom. I'm only going to do that on the left side just to show you that it can be solved on the right side using the other way, but it's far more difficult. Okay, I'm going to show you the other way to do this and essentially why it's easier on the left. So on the left, very simple now. To isolate A, I just need to bring over sine 55, which means when I bring it over, because this is a division sign, I got to make it a multiplication question on the other side. So A is equal to 7 times sine 55. Whoops. Divided by sine 45. Justin, get your calculator out and solve that for me. Okay. We'll plug this into a calculator. We'll get a number. Somebody help me out with it. While you're doing that, on the other side, did you get something? No? Okay. I'll bring it up on this calculator here.
I got it.
We have sine 55 times 7 divided by, where's division here? Oh, slash, good. Divided by bracket 45 sine and bracket, oopsie. Will that work? Yeah. 8.1. Okay, so we got a measurement of 8.1. For our other one, we're going to isolate C. Okay, I'm going to show you how this is actually far more difficult to do. Isolating C. Okay, I need to move. First, you would say the sine 180 over. Or there's another thing you guys would have learned early in elementary school when you have equivalent fractions. It has to do with multiplying. Cross-multiplying. That would be a faster way of doing this, okay? So we're going to cross-multiply. You're still going to see that this takes longer. So instead what we're going to do is we're going to cross-multiply. Bring C times sine 45 and 7 times sine 80. So then I have C multiplied by sine 45 is equal to sine 80 times 7. Our goal is to still what? Isolate what number or letter? C. So I got to move sine 45. How do I move that? We're going to have to divide. So then we're going to be left with C is equal to sine 80 times 7 divided by sine 45. And in this case, we're going to get C is equal to, we'll plug it in the calculator here, sine 80, so clear button. Good. 80 sine times 7 equals, divided by, bracket, 45 sine, and bracket, where's the bracket? There it is. Equals 9.7, let's say. Okay? 9.7. So, just to compare a little, if we compare this just a little bit, if you guys notice, when I just quickly flip this and I brought this over, it's a very quick way to do this. You could cross multiply first and then realize to isolate by c, so then you have to divide again. It's a whole extra step. And there's even more complicated way of actually explaining that without cross multiplying. So the best way to do this is whatever your unknown is in C or A, just flip the ratio and then isolate it in one step by bringing the bottom over to the other side, okay, by multiplying. That's the best way to go about doing this.